In this lecture of integration, we will perform the integration of 1 by 1 minus cos x with respect to x. In order to perform the integration of 1 by 1 minus cos x, we will write y is equal to integration of 1 by 1 minus cos x into dx. Now, we need to multiply numerator and denominator by the conjugate of 1 minus cos x. The conjugate of 1 minus cos x is 1 plus cos x. So, we need to multiply this integration by 1 plus cos x. Then we can write y is equal to integration of 1 plus cos x divided by 1 minus cos x into 1 plus cos x into dx. Now this 1 minus cos x and 1 plus cos x can be written as 1 minus cos square x, and this 1 minus cos square x can be written as sin square x. Now we need to separate the integration as y is equal to integration of 1 by sin square x plus cos x divided by sin square x into dx. Now this 1 by sin square x can be written as cosec square x, and we can write this cos x divided by sin square x as cos x divided by sin x into 1 by sin x. Now cos x divided by sin x will result in cot x, and 1 by sin x will result in cosec x. Then finally the integration becomes y is equal to integration of cosec square x into dx plus the integration of cosec x into cot x into dx. Now integration of cosec square x will result in minus cot x, and integration of cosec x into cot x will result in minus cosec x. So finally the result of integration is y is equal to minus cot x minus cosec x plus the integration constant c. If we take minus common, then y can be written as y is equal to minus cot x plus cosec x plus the integration constant c. In the similar way, we can perform the integration of 1 by 1 plus cos x. Here we need to multiply numerator and denominator by the conjugate of 1 plus cos x, which is 1 minus cos x. Now if you understand this integration, then perform this integration of 1 by 1 plus cos x and post the answer in the comment section. Next we will perform the integration of 1 by 1 minus sin x with respect to x. In order to perform the integration of 1 by 1 minus sin x with respect to x, we can write y is equal to integration of 1 by 1 minus sin x into dx. Now we need to multiply numerator and denominator of this integration by the conjugate of 1 minus sin x, which is equal to 1 plus sin x. So the integration will become y is equal to integration of 1 plus sin x divided by 1 minus sin x into 1 plus sin x into dx. This 1 plus sin x and 1 minus sin x can be written as 1 minus sin square x by applying the formula of a plus b into a minus b. This 1 minus sin square x can be written as cos square x. Now we can separate the integration as y is equal to integration of 1 by cos square x plus sin x divided by cos square x. Now this 1 by cos square x can be written as sec square x, and sin x by cos square x can be written as sin x by cos x into 1 by cos x. This sin x by cos x will result in tan x, and 1 by cos x will result in sec x. So the integration becomes y is equal to integration of sec square x plus tan x into sec x into dx. Now we will separate the integration and multiply dx with both the terms. Then the integration can be written as y is equal to integration of sec square x into dx plus integration of sec x into tan x into dx. This integration of sec square x will result in tan x, and the integration of sec x tan x will result in sec x. So finally the result of integration y is equal to tan x plus sec x plus the integration constant c. In the similar manner, we can perform the integration of 1 by 1 plus sin x with respect to x. In order to perform the integration, we need to multiply numerator and denominator by the conjugate of 1 minus 1 plus sin x, which is 1 minus sin x. Now perform this integration and post the answer in the comment section. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section, and don't forget to hit the subscribe button. See you in the next one.